Okay, hi again. So in this video, the purpose is just to learn how to use this table. Okay, it'll take us the whole chapter probably to wrap our heads around what we're actually doing. So be patient with me. Let me get a couple examples through and let's see if it makes sense. Okay, so I'm asked to do things in 5.1 in different ways. For example, I could ask you to find the area to the left of z equals negative 2.72 under the normal distribution curve. And let me fix this. Let's say standard normal distribution curve. And so picture-wise, and I make my face-to-face do this, I'd really like for you guys to do it also. 0 is here, negative 1, negative 2, negative 3, right? So where are you on this curve? And so we are about right here, and we want to the left. So is that answer going to be big or small? Well, it better be small, right? Because we didn't shade in much area. Okay, so I'm saying that this is a roughly negative 2.72. So to read the table, we come into the table and we look up negative 2.7 and we come over to the column that's going to have the hundredth spot, which is the O2. So that's this piece right here. Where does it meet? Right here. Was that a small value? Absolutely. So the area for this problem of the shaded space is approximately 0.0033. They used a bunch of calculus to come up with all these numbers on the table, and we just get to use the numbers. That's pretty exciting. Okay, another way you can ask the same kind of question is this. Find the probability that z is less than negative 2.72. Okay, that would mean the exact same thing. All right, so let's try another one. Let's find the area to the left of 1.49. So we have a z-score of 1.49. That's a positive value. So we come into our table and we go look for 1.4, which is on the second page of this table. 1.4, oops, I colored it in. And then, what did I say, 1.49? All right, I don't even know what I'm looking at. And 1.49 is this much. Oops. Is this much. So let's check to see if that makes sense with our drawing. Or at least doesn't contradict it, right? So we know here and here. And we know some stuff from past history, right? We know that this is 50%. And we know that this is 34%. Remember from our empirical rules. And then I asked for 1 point, so maybe 2 is about here because 3 is towards the tail, right? So I asked for something right about here. And so does our answer make sense? We're saying that this area is equal to 0.9319. This much was 84%. So I would say yes, this makes sense to us, right? Okay, awesome. Okay, let's try another scenario. We don't always want less than. So what if I wanted the probability that z was greater than negative 1.57? In order to look this up, this is the same as asking what is the area to the right of z is equal to 1.57. And take a look at your take a look at how this would look. It would be to the other side, right? So that's the complementary event. So in order to do a less than situation, we read straight from the table. To do a greater than situation, we have to do 1 minus whatever we find from the table. So let's go look up this negative 1.57. Negative 1.5 is right here, and the 7 is here. So we come down this column and we're looking at this value right here. And so in order to answer this question, 1 minus 0.0582 is the work we need to do. So the area would be 0.9418. So it's all about how that question is worded. Okay, so greater than, we're going to have to do 1 minus. Less than, directly from the table. The third situation is when you want to know in between the two. So check it out. What if I want to know the area between a z-score of -1 and +1? Well, we already know that this should be roughly 68% or 0.68 from our empirical rule. So let's see how this would work on our table. If we were to look up a z-score of 1, which is the bigger one, that's our bigger value, it would give us this area. So here's z is 0, here's z is 1. It would give us all of this area. If we were to look up a z-score of -1, it would give us this area. So if we want what's in between, does it make sense that we just need to subtract those two values? Okay, so since I'm on the negative page, I'm going to go ahead and grab the z-score for -1. So here's -1.0, and then I need the column that has the zeros. So this guy has an area of 0.1587. Going to the table for the positive values, looking for +1, notice the 0 columns on the other end this time. So I need that 8413. So this guy's area is 8413. If I subtract those two, what do I get? Well, I'm going to live on the edge here. You're going to get to see me do math early in the morning without my calculator. But that would be 6, and then I lose the 0, so that'd be a 2, and then that's a 3, so this is an 8, right? How am I doing? And then I want that to be a 6. Ta-da! Now, what was it supposed to be? 68%? Well, remember the empirical rule was a rough estimate. So this is pretty good, 68.26%. Awesome. So a recap, super quick. If you have greater than, you're going to do 1 minus. If you have less than, you're going to do exactly what the table says. And if you need in between two, then you'll find the bigger value, then find the smaller value, and subtract their two areas. Ta-da! Okay, give it a try. That should cover 5.1 and 5.2, honestly. So I'll come back with more examples in 5.2 just to drive you crazy. I want to make sure you have more than enough to go over the deep end. No, I'm just kidding. I want you to be successful. Have a great day. Bye.